Hey everybody, in this video we're going to be covering a complex, and I say this relatively speaking, complex trig equation involving trig functions within exponents of numbers. So at first this looks pretty daunting, but I'll show you how to go around this. Okay. So we got an equation, we got sine squared up here, we got cosine squared up here. Our goal is to solve for x, and if the x's are, if the variable x is separated, we gotta bring them together somehow, okay? So first thing you wanna do here is figure out a way to bring the sine squared and cosine squared together. And the formula that I have in mind that can be used here is the Pythagorean identity formula from your trig identities. So you do need some background in trigonometry in order to do this, but if you're interested in learning more about this chapter of trigonometry, refer to my other videos in the playlist, and yeah, you'll be ready for this question. So I'm going to be using this Pythagorean identity formula. Isolate for the sine squared x. So what I want to do is I want to write everything in terms of cosine, because right now we have sine and cosine, two separate trig functions. So if I isolate for sine squared x, you get 1 minus cosine squared x. So what I'm going to be doing is I'm going to be replacing that sine squared x with that. Okay. So here's what's going to happen. You get 1 minus cosine squared x plus 2 cosine squared x is equal to 3. Okay. So what happens next? How do we go anywhere from here? Because there's a plus sign here between the two terms, so we can't really do anything. If this is a multiplication sign, that would be a different story. But what you can do here is you can use the quotient rule of exponents and then rewrite this as 2 to the 1 divided by 2 to the cosine squared x, right? Okay, at this point, we can use substitution. So what I'm going to do is I'm going to be substituting 2 cosine squared x with a new letter, a new variable. So this can be whatever you want. In this case, I'm going to be using u, just because I feel like using a u, right? No particular reason. Okay. And if I do that, I'm going to end up with 2 over u plus u is equal to 3. So now that we look at it like this, it looks like a pretty simple equation. So you would solve this by multiplying by u on both sides, because we don't like having variables in the denominator. If you distribute this, the u's cancel out for the first term. You get 2 plus u squared is equal to 3u. It's a quadratic equation, so in order to factor this, we're going to put everything on one side. So I'm going to move everything to the left side, and I'm going to put it in descending order. Okay. Let's trinomial factor. So let's brush up on our algebra 1 here. So split up the u squared, u and u. Split up the 2, 1 and 2. Cross multiply. U times 2 is 2u. U times 1 is u. These two products have to combine to become minus 3u, and the only way to achieve that is by making them minus. And by default, that would make these guys minuses as well, and I gotta make sure that minus 1 times minus 2 gives you positive 2, which it does. Both of those conditions are satisfied, so now I can swipe this away, I can swipe that away, and turn them into factors. So you get u minus 1, u minus 2 is equal to 0. Therefore, you get u is equal to 1 and 2. Okay? But this is not our final answer. We need to write our answer in terms of x. So what was u to begin with? U is equal to 2 cosine squared x. So I'm going to replace the u with that. So 2 cosine squared x is equal to 1. And also, 2 cosine squared x as an exponent is also equal to 2. Okay? So a couple ways we can approach this. This 1 here can be written as 2 to the power of 0. So because now the base numbers are the same, we can set the exponents equal to each other. So we get cosine squared x is equal to 0. And if we take the square root on both sides, you'll get cosine x is equal to 0. All right. So we're very close to finding the answer, at least down this path. We have this other equation over here. This 2 here has an exponent of 1. The base numbers are the same. So then we can equate the exponents. So we get cosine squared x is equal to 1. And if we take the square root on both sides, and while we're at it, we got to put a plus minus here. We get cosine x is equal to plus minus 1. So within this equation, we get a split of cosine x is equal to cosine x is equal to 1, and then cosine x is equal to minus 1. Okay, so we got to work with 3 things here. All right, so what's the best way to solve these? Well, 0 and 1 are considered pretty, they're benchmark answers. So 0 is the midline, occurs at the midline of the cosine graph, and 1 and minus 1 are your maximum and minimum respectively on a cosine graph. So rather than using a unit circle here, I'm going to use a cosine graph to solve this. That'll be quicker. So let me show you. So draw your cosine graph. Your cosine graph looks like this. Okay, so that's your cosine graph. Where does 0 occur? First of all, let me label the benchmark angles here. So 1 full cycle is 2 pi. This is pi. This is pi over 2. This is 3 pi over 2. So again, where does 0 occur? AKA, where are the x-intercepts? It's here and here. So that would yield x is equal to pi over 2 and 3 pi over 2. For now, we'll deal with what happens, with other, ongoing cycles. Wouldn't there be other answers? We'll get to that in just a little bit. So let's look at the same graph again. I'm just going to draw another one because the other one's quite messy. So where does the height of 1 and minus 1 occur? So if you look over here, the ones occur right here, and right here, which correspond to 0 and 2 pi. And the minus 1 occurs right here, which occurs at pi. Okay, so there's a lot of answers here. So we have an answer at 0. We have an answer at pi over 2. We have an answer at pi. We have an answer at 3 pi over 2. And we also have an answer at 2 pi. And then that's just going to keep going. It's going to keep happening over and over and over in both directions, in the right direction and the left direction. And notice all solutions are pi over 2 apart. They're all pi over 2 apart. Therefore, here's how we can summarize all the values of x. Pi over 2 n. Pi over 2n. So let this sink in. So where n represents all integers. So what does this mean? So let's plug in like 0, for example. If you plug in 0 for n, you get 0 degrees or 0 radians, which is one of our solutions. If you plug in 1, that's pi over 2. That was one of our solutions right here. If you plug in 2, we get pi, and that was a solution right here. If you plug in 3 pi over 2, that's a solution there. And if you plug in 4 for n, you get 2 pi right here, and then so on and so forth. Whatever integer you plug in, all those solutions will be taken into account. So therefore, this will be your answer. And I hope you enjoy that. If you did enjoy that, and if you would like to ask any other questions, just try me. Easy to hard, whatever. I will provide a solution in the form of videos. And yeah, I'll see you guys next time. Take care.